So one of the most common solid state lasers is what's called the YAG. And so the YAG, that stands for neodymium doped yttrium aluminum garnet host crystals. So YAG is the yttrium aluminum garnet. So garnet is the type of crystal. And you can see here is the chemical structure of that solid. So it is a solid. It's got a neodymium 3 plus that is embedded in this host crystal. So the crystal, the vast majority of it is this yttrium aluminum garnet. So the vast majority is YAL and oxygen. However, there are some few neodymium 3 plus ions in that crystal lattice. So it's an alloy, right? And so you can see here the laser action is created from the neodymium 3 plus. Okay? And so the really powerful laser line that you get out of this is the 1064. So that's IR, but you get really powerful, intense radiation out of this YAG laser. Okay? And so you can see here the water flow. So that shows you this thing has to be cooled. So these are definitely pulsed lasers that use a flash lamp as the pumping source. Okay? And that 1064 doesn't sound very convenient. However, using other devices, so you can see we've got the laser beam coming out here, you can then pump that laser beam into another resonating cavity and get different integer wavelengths out of this. So commonly from the 1064 nanometer, through another resonant mode, you can create 532. So that's half of that wavelength. And people will often use 532 from a YAG laser, and hopefully that number is familiar. That's typically for the Raman spectroscopy technique. So the YAG laser with what we often call a doubling crystal. So that doubling crystal halves the wavelength, which means it doubles the energy, right? That's typically where we get that 532 Raman line, okay? And then obviously using other resonant modes, we could keep scaling this wavelength down by half integers. And so that's what's commonly done with the YAG because it creates such a high intensity 1064 pulse. You can also get really high intensity 532 pulses out of that as well, using one of these, like we call them, a doubling crystal. Okay. So let's see. I think that's about all that I have for my very last lecture here. I'm going to play us out, assuming my music is still on. There we go. Folks, it's been a crazy year. I never thought I'd be recording lectures in my living room for a whole year the way that I have. So I just want to say I appreciate all the hard work you've done. Keep going. The world needs more scientists and more doctors. So keep going, keep learning, don't give up. Okay, folks. My son's yelling at me now because the music's too loud. Okay, bye-bye, folks.